In this lesson, we're going to talk about intake rates, and this encompasses a couple of different definitions that really talk about water going into the soil. Some of these you may not use on a regular basis in irrigation repair or system installation, but it's important to know what these things mean as you're reading through literature so that you can understand, and we'll get into a little bit of this later on when we talk about different aspects of irrigation systems. But the intake rate refers to the amount of time that it takes for water to seep down or soak down into soil. It's going to be a little bit different for each type of soil. For instance, with sand, the rate is going to be pretty fast, and it's not really going to change a whole lot because generally sandy soils will pretty much just accept all of the water that goes down unless it's just, a flood event or something like that. And it goes pretty quickly. Whereas on the opposite end of the spectrum with clay, the intake rate is a lot slower. And there's some charts floating around out there. And I may not give it to you. I mean, it's not really that important except when it comes to the selection of sprinkler nozzles, and we'll definitely get into it at that time. But with clay, you have to go with nozzles that have a lower precipitation rate. And the precipitation rate is really referring to, how quickly a sprinkler is going to put water down. And for clay, you want to go with some of the slowest precipitation rates that you can find. And with clay, it's funny, if you see a graph of it, it's more or less like a bell curve where it's slow when it very first starts off, and you have to kind of soak in the very top layer of the clay and loosen it up. Sometimes you'll see clay get real crusty on the top, and you've got to soak that in, and then the rate goes up, meaning that it's accepting more water until you get towards saturation, and then that intake rate slopes back off. Now, infiltration, when you see this word, that's really referring to the downward motion of the water in your A and B horizons, which are basically the top two layers of soil that you're really going to have root systems in. The A horizon maybe being the top 6 inches, and we've talked about that, and then the B horizon being below that, which sometimes you will get roots down into that. But percolation refers to that downward motion in the C horizon. And really, if you think about what percolation refers to, is that the kind of bubbling up effect. And really what's bubbling up is the air kind of coming up out of the ground as the water soaks down and displaces the air so that water can get down into the pore spaces. And what the pore spaces are is those spaces in the ground that aren't occupied with something else other than air. If you could take a cross section of the ground, like I've kind of shown in some of the previous illustrations, that you have rock and you have organic matter and your soil particulates, and everything else that's not taking up space physically is filled with air. And so that is the space that water is going to occupy as it goes down and infiltrates down into the ground. And saturation refers to when all of the pore spaces have been completely filled with water. Now, field capacity is when basically all of the large pore spaces have been drained with water. And that's, your average watering event. That's what it's really going to accept there, is basically the large pore spaces. And that's like your average watering event. But when you see the words permanent wilting point, that refers to when all of the pore spaces, both the large and the small pore spaces, have been completely drained with water. It's just filled with air. And basically, when you're at the permanent wilting point, that means that your plants are going to die from that point unless they're already dead at that point. So hopefully you have a watering event that's coming up that'll fill those pore spaces back up. But usually when you get to the permanent wilting point, that means that you've been in a drought, or you're out in the southwest in a very arid situation. And, that's why they water a lot more frequently out there depending on the soil type. But the available water is the calculation of water between field capacity and the permanent wilting point, which is basically the overall calculation of how much water that a soil can accept. Now, that may not be what happens on every watering event. We're definitely not trying to completely saturate the ground every time that we water. And usually in all of these calculations or these terms are going to use inches of water, and it's usually referred to as an acre inch of water. You probably won't get into those kind of calculations a lot. It's just helpful to remember that when we talk about scheduling and we talk about, say, an inch of water per week, or maybe a quarter inch or a third of an inch of water per watering event, to kind of put that into some perspective for you.